Welcome. In this video I'm going to show you how you can obtain the mode for binned data using Python and my stikpetP library. I'm using Jupyter Lab with an Python version 3.12, and this video will focus on how to obtain the mode, not so much on the binning itself. For that I have a separate video, so if you want to know how to determine how many bins you should create and how to create them, there are separate videos for those. To show an example, I need some example data, so I'll first import pandas so I can load in the general social survey data from 2012, adjusted for some example purposes. After I loaded the data, I actually don't need all of the data, I just need a numeric field. So age seems like a good candidate, so I'm going to be using age, remove any of the missing values. There is actually an 89 or older category, so I'm going to replace that with 89. I set that as a coding, as a dictionary variable, and then just use replace. And also make sure that everything is numeric by using toNumeric. So that should give me numbers only. My library is not directly available by using pip install and then stikpetP, but you really need to refer to my GitHub account. Once you've installed it, you can load it just as any other library. And then the function me measures mode bin becomes available. It takes as input the data, of course. You can specify the number of bins that you want. You can also specify the bins itself. Should it include the lower bound or otherwise the upper bound? Adjust the data, or not the data itself, but the bins a little bit so it will include the minimum and maximum. What to do if all the frequencies are equal, or frequency densities I should actually say. Should it then just return that there is no mode, or should it return all of them? You can also specify what it is you want to see, either none, then it will simply show the bins themselves as the mode. You can use the midpoint of those, or quadratic, which tries to do a little bit of a smoothing and then determine where the mode might probably be within the bin. Let's simply take it for a spin. We have the function, we have our data, so that should give us immediately a result. So apparently the mode is the bin 30 but under 36 with a frequency density of 39.5. If I specify my bins myself, each time with a lower and an upper bound, then I can also set those, and then in this case apparently the mode is then 25 but under 30 with frequency density of 32.2. If you prefer to see the midpoints rather than the mode itself, then just set value to midpoint or to that quadratic, and then you get, in this case, 27.5. Alright, I hope this video was helpful, and thank you for watching.